Okay, let's continue our discussion with the third concept, which is about supernode. We need to explain, or we need to define what is actually supernode. Okay, so supernode is actually a configuration formed by enclosing a dependent or independent voltage source connected between two non-reference nodes and any elements connected in parallel with it. Let me explain about this concept. Okay, it means that supernode is formed by enclosing a dependent, okay, here your dependent voltage source or independent voltage source. So you must remember dependent in this circle form, while independent in this diamond shape of your voltage source, and it is connected between two non-reference nodes. Non-reference means except your ground, and any elements connected in parallel with it. Let me explain about the first example. Okay, look, this is your VB, right? So your VB is actually your voltage source, which is your dependent voltage source, right? So this is the supernode situation. Why? Because VB is connected or formed by enclosing a dependent voltage source connected between two, this is one, this is two, non-reference node, and any elements connected in parallel. So R1 is connected in parallel with it. Yeah, so this is VB here in this green line is your supernode condition. Now let's have a look to the second example. If we have VA over here, R1, R2, IB, and let's say this is IA. So this is your supernode because your VA is connected in between these two non-reference nodes, which is your this node and this node, as well as except your ground. Now, how are we going to solve any supernode equation or any supernode circuit? Okay, we still need to use a nodal analysis, but remember, we need to generate, or we need to produce, number one, support equation, and number two, supernode equation. What is actually support equation? Support equation is actually for the voltage drop in between the combined nodes compared to the voltage source, while supernode equation is a combination of KCL equation for the respective nodes. Don't worry, let's have a look to this example for a better understanding. Okay, let's say we want to write the support and supernode equation for the following circuit. Right? We need to observe why this circuit is considered as a supernode circuit. Okay, let's say we have VB, we have R1, R2, IB2, and IB1. Now, if you still remember, this VB is located in between these two A and B non-reference node. This is why this is supernode condition. As I said previously, we need to produce number one, support equation, and number two, supernode equation. What is actually support equation? Let me redraw, right, from this one to this one. So I have this node A and node B, and this is my VB. So the potential difference definition of VA and VB, which is here, VA minus VB equal to VB here. So meaning that this node and this node is referred to this equation. VA minus VB equal to VB. Why? Because positive VB. If let's say I have something like this, This is A, this is B, then VA minus VB equal to negative VB. Right? This is another examples. Now, how are we going to write our supernode equation? You must remember that supernode equation is related with a combination of your KCL equation, right, for the respective nodes. So we have right now A nodes and B nodes. So this is VB. You must remember, right, your KCL must respect the fundamental of KCL, whereby summation of I entering equal of summation of I leaving. So I enter equal I leave. So right now, because as you can see from here, if you have IB1 here, so this is your current of your IB, so definitely your I1 will be in this direction, and when they are having this junction, so I2 will be flowing with this direction. If you have IB2 here in this direction entering node B, so definitely I3 will be leaving from node 3. This is why summation of I enter equal to summation of I leave, summation of I enter node A plus summation of I enter node B. Okay, equal to summation of I leave node A plus summation I leave node B. So what is I enter node A? You see, I enter node A, I1. Okay. I enter node B, I4. Right? Equal to I leave node A. What is I leave node A? I2. Okay. I leave node B, I3. And you must remember, right? I equal to V over R. So what is your I1 here? I1 from here is your IB, right? Okay. But your I4 here, right, is actually equal to your IB2. Okay. But I2 here, I equal to VA over R1, which is actually VA minus 0, yeah, divided by R1, plus here your I3 is here, VB over R2, which is actually VB minus 0, which is 0 is your ground, divided by R2. This one, VA minus 0 divided by R1. Okay, I hope you already understand the two concepts that being discussed throughout these previous videos and these videos. The previous videos we discussed about the concept 2, whereby your circuit with current and voltage source, and this video we discussed about your supernode.